Hi, I am Stefan. I'm the founder of Talent Data Labs. Welcome to one of our webinars about assessment tools. Today we're going to talk about general mental ability, which is one of my favorite tools to talk about in the wealth of assessment tools that we have. Basically, general mental ability measures your G factor, which in research is used to describe cognitive ability or intelligence, as some others might relate to it. This is a really important data point that we always use to predict behavior and predict certain performance levels of talent in organizations. We'll go into this a little bit more in depth, and at the end of it we'll start looking at a case. But basically I wanted to walk you through the very concept of our testing suite a little bit. So we as a company, we really want to make you as a user understand how talent can perform best in an organization, and we want to give you the infrastructure to be able to do so. So three of our major tools, as you can see here, are cultural fit, personality, and of course today's subject, general mental ability. This episode will be entirely dedicated to general mental ability, and the reason we want to give you a case as well is because I don't necessarily think that the majority of users use mental ability in the perfect manner. It's not always true that a higher score is better, and we'll see that in our case. But let's dive into general mental ability in general first. Alright, so GMA is scientifically accredited. So Schmidt and Hunter are two of the most famous researchers that have been researching performance over the last 100 years and found that GMA correlates substantially with performance up to 0.56 or something. That's almost 25% in more mathematical terms. Basically, TDL GMA consists of three parts. Number one would be analogies, and we call this analogical reasoning. Number two would be sequences, logical reasoning, and number three would be spatial reasoning with unfolding different set of exercises. Let's look into each and every one of them into a little bit more details. Let's look at the first one, analogical reasoning. Analogical reasoning basically is a set of four images, and these images have certain properties. As you can see here, on the left side, you find a couple of circular shapes, three of them, and a question mark. The main task of the user is to identify what the question mark should look like. And to do this, they are given a hint. The hint is basically the top row. So on the top row, you see two shapes, two circular shapes, and each of them has a slight, or in more difficult questions, a major difference in it. What we can see here is that the small ball that you can identify on the right side of the top left shape has moved two places along the internal line. This is what we call a dot movement. This dot movement has been identified by me now as a sort of two-jump approach to the left, or clockwise. So what I as a user now have to do is have to identify what does that mean on the second row. So if that two jumps to the left would happen on the second row, how can I translate that into the question mark? So basically two jumps on the left or clockwise jumps would translate into two more jumps to the left or clockwise jumps. In this case, it would start moving to the right. So we can identify the top left picture as the right answer. And it's basically going to get harder and harder as the shape starts rotating and flipping, and the small trapezoid at the end is the exterior is going to move. It's going to be a lot of fun for the users. Now the next one is sequences. So logical sequences are a series of numbers or letters or other type of things that move in a certain order. The goal of the user here is to identify what is the missing number. Often we put this number at the end, but in more harder problems we put it in the middle as well. So in this case, what you see a series of numbers, 7, 10, 8, 11, 9, 12. Obviously you see, okay, from number 1 to number 2, from 7 to 10, we see a difference of 3. From 10 to 8, we see a difference of 2. And then from 8 to 3, we see a difference of 3 again. We have here identified a pattern. Plus 3, minus 2, plus 3, minus 2. Therefore, the logical answer must be, after 9 to 12 is a plus 3, so we expect a minus 2, is 10. Answer B. This is great for figuring out how well people are able to find patterns in seemingly ordinary data. This is a skill that's very useful in making strategic decisions. And now to the last one, the newest one in our section, is basically the spatial reasoning test. Spatial reasoning is a tough exercise. It's really difficult. You have to unfold a cube with your mind. So what you're basically doing is you're looking at let's call it a map. A 2D shape of something that, if you fold it, will become a cube. Now, in this test, we ask you to identify which of the cubes can be folded out of the 2D shape. So what you have to start doing in your mind is basically folding up the cube so that you can identify which one is the right one. And in this one, you clearly see that the yellow triangle and the black square and the white circle are already forming the corner of a cube if you would fold that, and therefore must be the right answer. Note that there's only one right answer, never more than one. Let's take a look at the case that we want to present to you today. Today we're looking at an American consumer goods company. This consumer goods company has a really challenging application process where they select for a lot of intellectual capacities, a lot of performance in previous jobs and education, which we know are traits that are usually related to a high level of intellect. Basically what we're trying to do is we're trying to figure out to which extent this company and their selection process creates the profile for a user, or creates the profile for a candidate, that will perform better in that company. At the end, we want to figure out how we can optimize this profile to make sure that we don't do anything irrelevant, do anything superfluous, don't do too much, not too little of something. And we're basically going to assess that through our process. I'll walk you through how that works, but first let's take a look at this graph. This graph basically shows that the cost of hiring people that are really smart is substantially higher than the cost of hiring people that are just smart. Now, we want to make sure that we are not measuring the wrong thing here. So we really want to focus on cognitive ability, and to do so we want to deploy our tests and want to measure how well people perform in that general measurement of aptitude range. So what we do is we take a group of stakeholders from the company, gather them, make a fun exercise, make a fun internal sort of competition out of it, and get those people to do their general measurements of aptitude, their tests basically. At the end of it, we made sure we assessed everyone and gave them a report that they could use to learn a little bit about how you can deal with certain levels of intelligence and what sort of tasks are easier and better for you to do. So it's also fun for them to do this. Then we looked at the scores and we tried to correlate them with performance so that we could optimize performance over these intelligence scores. And at the end of that, we decided that we would create a model that we would deploy in the organization that could automatically hire better or hire more specific people that would be a better fit for the exact requirements of the job. Meaning that we would find people with the exact configuration of mental ability for the function. Well, So first, in the assessment phase, we're going to take a look at another graph. We found that for someone to perform well in this consumer goods company, you didn't need as high of a level of intelligence as we measured. So on the left side, you see actually the predictive level of performance based on this intelligence score. So highest performance set in a bracket that's that's slightly lower, but 5%, 4% lower than the GMA that we saw in the user group itself. So we saw that in the candidates for the jobs at this consumer goods company. In order to optimize this group, what we want to do is we want to measure people's intelligence and score them higher if they had a somewhat lower intelligence, not low, just somewhat lower. This created an estimated cost decrease of about 19-20% effectiveness, basically. So ultimately, what we did here, by lowering the intelligence necessary a little bit, we made sure that we could decrease the cost per candidate by a lot. Because as we saw on the previous graph, salary and cognitive ability correlate positively. Alright, so the conclusion of all of this is basically that by using the analysis, by looking at all the stakeholders, by trying to figure out how much intelligence do they specifically need, and by looking at how much we were actually recruiting right now, we could find a way to optimize the recruitment process so that we could cut time, we could increase satisfaction because people are doing less tasks that they feel are below their intelligence levels, so it's more optimal there as well, and we really improve the performance cost ratio by a lot by deploying our model and by looking at intelligence in a little bit of a different way. So this is one of the ways you can really deploy this in your own analysis, or that you can use our software to figure out how people perform and where. Thank you very much for listening. Hope to see you again soon.